Hello and welcome back to the course on R programming. Today we've got a pretty cool topic ahead of us. We're talking about naming dimensions. And so what is this all about? Well, let's dive straight into it. Let's imagine that we have a matrix of 15 elements and all these 27 numbers and 1 0. So how do we access the 0? Well, from what we already know, it's pretty simple, right? All you have to do is type in the name of the matrix, which is A in this case, and then in square brackets the number of the row, third row, fourth column, and you will get your 0. But what we're exploring today is the fact that in R you can actually give your rows and columns names. So you can rename that and you can rename that. Let's start with the columns. Let's have a look at an example. Let's say we don't want to use those numbers anymore and we want to give our columns names. And we'll call them P, Q, R, S, and T. And in this case, if we have a matrix like this with named columns, how would we access the 0 now? Well, it's also pretty simple. All you have to do is type in the name of the matrix, the number of the row, and the name of the column this time. And make sure to put it in quotation marks because it's a name and you're calling out the column by name, so you need the quotation marks. So this way you will access your 0. And now let's have a look at the rows. Let's say these names disappear, the current generic ones, and we give it some interesting names like hello, X, and best. Now, bear in mind here that you can use a word, a letter, even a number, but of course the number will be represented as the character of the number, not just the number itself. And in this case, if we want to access the 0, we would type in A, then best in quotation marks, and S in quotation marks. So we're calling out the row and the column by their names. Now, what I wanted to point out here is that all three of these approaches for accessing the 0 are actually correct, because the numeration of the rows and the columns is going to stick with the matrix forever. Regardless what you do with the matrix, the rows and columns are always going to have numbers. So whichever one of these three approaches you use is actually going to be correct. And in fact, there's a fourth approach, as you can guess. One we haven't outlined here yet is when you call out the row by its name and the column by its number. So it's the fourth approach here. Although, can you tell me what is wrong in this representation? That's correct. We forgot the quotation marks, so let's put them back in place. So there we go. 4 approaches to access your 0 in a named matrix. And of course, it doesn't have to be a 0. You can access pretty much virtually any element in this manner. All right, so now that we've looked at matrices, let's have a look at vectors. Because surely if we have such a great and cool concept for matrices, there has to be something similar for vectors. And that's correct. Here we've got a vector of 5 elements, and it's not a named vector, it's just a standard vector where the elements have their numbers 1, 2, 3, 4, 5. Now what we can do is give these elements names, and therefore turning the vector into a named vector. Let's use the names A, B, C, D, and E for simplicity. And how would we access the 0 in this case? Well, it's also pretty straightforward. You can either just say V4 because that's the 4th element, or you can say V and in quotation marks D because that element now has a name, which is D. And this brings us to the end of today's tutorial. I look forward to seeing you next time, and until then, happy coding. Hello and welcome back to the course on R programming. Now that we've talked about the theory of named objects, let's see how it all works out in practice. So here we've got RStudio, and this is what we talked about last time. We talked about the matrix function, the rbind function, and the cbind function, and all of them were used to create matrices. So now let's create a new file, and here we're going to start with named vectors. So hashtag named vectors. All right, follow along, and we're going to create a vector. Let's call him Charlie. Right, let's give this vector a name, and we'll put the numbers 1 to 5. So very simple vector. If we type in Charlie now, we've got our vector 1, 2, 3, 4, 5. Beautiful. Okay, so let's make it a named vector, right? Let's give it names. Give names. Well, we need the names function. And the way it works is you type in names, and then in brackets, you type in the object that you want to check the names for. So first thing we're going to do is we're going to check the names. So if you just run it like this, names Charlie, it will tell you the names of the elements. And right now, it's just returning null. And in R or in programming, null just basically means nothing. So it's not anything, not something, it's just nothing. There's there are no names and it couldn't look them up. They're not even zeros, they're not even empty values, they're just null. There are no names. And that's why we're getting a null, because indeed there are no names for this vector. So let's create some names. How do you perform this procedure? Well, this is going to be interesting, especially for those of you coming from a programming background, because what we're going to see now doesn't happen often in programming. So here we've got the vector named Charlie, and we've got this function names around Charlie. And as we know about functions, this function returns a value, right? So in this case, it returned a null. But what you can actually do with this specific function is you can assign it a value. So I'm just going to type it out and then I'll explain what we're doing. So let's say we want to assign this vector names just like in our example, and we want to call it A, B, C, D, and E. And now what we're doing here is we're actually assigning this vector of 5 elements to a function. Isn't that crazy, right? It's pretty strange. Well, the best way to think about it is R allows you to treat this part on the left as an object. So when you're calling, and that's not for all functions, it's just for specific functions and, for instance, names. So when you're calling names Charlie, it's like you're looking at the characteristic of the vector Charlie, which is its names, right? You can just run this bit by itself and then you'll find out the names, or you can assign it a value. So if you think of names Charlie as an object, as another vector that always accompanies Charlie, then it'll kind of make more sense. And so now if we run this line, what will happen is Charlie will get some names. And let's check out Charlie. So if you look at Charlie now, you'll see that this is now a named vector. Those are the values 1, 2, 3, 4, 5, and those are the names above them, A, B, C, D, and E. So if I want to access that number 4, then how would I do it? I would say Charlie, and I would type in the name of that element, which is D. And I run that, and there we go. So I get back this number 4. Okay, awesome. And now I can also check the names of Charlie, right? So if I run that, A, B, C, D, and E. And by the way, here you can see that concept that we talked about before, that everything in R is a vector. So even though we're calling out just one element, it's returning a vector of length 1, which is also named vector. It has the name D for this only one element. But let's not get bogged down with that. That's just to reiterate something we talked about before. All right, so we've got the names of Charlie over here, and Charlie is a named vector. There it is. Now what we want to learn is we want to learn how to clear names, right? So if we want to clear names, how do we do it? Because some people get very upset that sometimes vectors, or as we'll see, matrices have names. There's a very, very easy way to clear it. Just say Charlie, and instead of giving it some names, just type in null here, right? Do that, and then when you look at Charlie now, he won't have any more names for the elements. And that's how you clear names from a named vector. Okay. We're done with named vectors. It's all pretty simple stuff, right? As long as you think of this as an object, then you will see that it makes sense that you're assigning those vectors some values, and it's a pretty simple function, names. Okay, let's look at the next thing for today, which is naming matrix dimensions. Okay, so let's create this matrix. First, we're going to create a temporary vector, temp_vec, and into this vector, we're going to put some values. And I would like us to practice the replicate function because we haven't used it in a while. So what are we going to replicate? Remember, with replicate, we can just take an element, take an object, and replicate it a couple times. So we're going to start with a vector. This is what we're going to put inside replicate. So we're going to have a vector A and B capital, and then let's say Z, Z, right? So this is a simple vector of 3 elements, A, B, Z, Z. And now what we're going to do with it is we're going to copy this vector and we're going to put it into replicate, and then we'll say replicate it 3 times. So if I run this part by itself now, let's just put it aside for a second. Now what we'll get is we'll get A, B, Z, Z, we'll get A, B, Z, Z, and we'll get A, B, Z, Z again 3 times. Now what I wanted to show you today is a cool trick. In replicate, what we're doing right now is we're telling it how many times to replicate. So it's the same as saying times equals 3. So if I run this, I'll get exactly the same result. 3 times this vector has been replicated, and it's just been glued into one long vector of 9 elements. But what else you can say is you can say instead of times, you can say each. And if you say each, what will happen is instead of replicating the whole vector, each one of these elements will be replicated 3 times. Let's have a look. If I run that, now I get a different story. I get A, B, 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 Z, Z, Z. So that can be convenient in some certain circumstances. In fact, that's what we're going to use today. So just to make a note of that, that's how you can also use replicate. That's a kind of a different way to replicate your values that you're supplying to the vector, to the function. So there we go. That's how we're going to use replicate. Let's run that and let's look at our temp vec now. So as you expect, it's AAA, BBB, ZZ, ZZ, ZZ. And now what we're going to do is we're going to create a matrix out of this vector. Now I did say we won't be using the matrix function a lot, but in this case, let's give it a go just to practice and kind of sink in that knowledge that we learned in the previous tutorial. So temp vec, right? We're calling the matrix function. Then we have to, as you can see here, we got to supply the data. Then we say how many rows, how many columns. We know that our vector has 9 elements, so we'll make it a 3 by 3 matrix. If I run that and I call Bravo, you'll see that I've got our matrix. And it's nice and neat. It's AAA, BBB, ZZZ, because that's how our vector was structured. And as you can see, it's not a named matrix. It doesn't have rows names or column names. Let's fix that. Let's explore how we can do that. And we're going to explore a function that's very similar to the names function. We're going to look at row names. We'll start with row names. So row names, Bravo. If I run that now, I get a null because there are no row names. And just as with names, I can supply some values here. So let's say I want to supply values how, are, and u. And I can even put a question mark here. So if I run that and now I look at, let's say Bravo, you'll see that this matrix now has row names. And same thing for columns. So I can call the function call names and supply Bravo. If I run that, no call names. If I assign some values, so let's say we'll assign X, Y, and Z. If I run that, if I look at Bravo now, you will see that we've got both row names and column names. So let's say we want to put a 0 in, not in there, let's put a 0 in here, in the middle. Let's put a 0 in the very middle. How would we do that? We'll say Bravo. So we can go 2, 2, right? Because it is the second row, second column, or we can say R because that's the name of the row, and then in quotation marks, and then we can say Y because that's the name of the column. And if we just run that, we'll get the value in there, which is a letter B. And if we want to put a 0 in there, we just put a 0 in there. And now if we look at Bravo, you'll see that there's a 0 in the very middle. And finally, if you want to, we can also check row names, right? We can check row names or call names, choose whichever one you like. We can check, there they are, that's the row names for Bravo. And if we want to get rid of them, so this might be useful, some of you might find this useful because sometimes you get named rows or columns which you don't really want. To get rid of that, same thing, just type in null and look at Bravo. You see, we got rid of the row names, the column names are still there. Okay, so that's how you rename matrices and vectors. And as you can see, I'm sure you guys will agree, this is all very simple stuff. But as we'll see throughout the rest of the tutorials of this section, it is very important to know how to work with named objects in R. And that brings us to the end of today's tutorial. I look forward to seeing you next time, and until then, happy coding! Hello and welcome back to the course on R programming. Today we're going to finally get our hands dirty in the basketball dataset. And also we're going to learn about matrix operations while we're at it. Alright, so let's get started right away. Let's see what kind of tables are at our disposal. So we can see them over here. Let's type some of them out. So let's start with the games table, for instance. Matrix. This is a matrix. So here we've got the players and we've got the years. And as we now know, this is a named matrix. So basically it's got row names and column names. So if we check row names of games, we will see that that's the names, and same for column names, we will get the similar result. So let's check games. We see that it does have games. So basically it's a matrix, right? And now we know how to access it as well. So if we want to, for instance, check how many games LeBron James played in 2012, we would say games, and then instead of trying to figure out what row LeBron James is on, third row, and then what 1, 2, 3, the number of the column. Here we can just simply say LeBron James and then comma, and in 2013 or 2012, whichever year, let's say we want 2012, we check that, we get our answer, 76 games. So here you can see that that is correct. LeBron James played 76 games in 2012. Okay, great. So, but now matrix operations. What can we do with matrices? Well, we know that with vectors, we can do the same operations as we would do with just variables, right? So we can add vectors, subtract, multiply. We'll explore all of that previously in the course. But now, can we do the same things with matrices? Well, yes, of course we can. So let's take another matrix that we have. Let's say field goals, right? Field goals. So this is how many field goals each of the players scored in each of the years, right? So what we can do here is, let's say we want to find out how many field goals every single one of these players scored per game. One way to do it would be to go through every player, through every year, and divide the number of goals by the number of years, like in a loop, or it would even be a double loop, right? You would have to loop by the players and by the years, but that's overly complicated. So mathematicians and statisticians thought it was overly complicated, and they decided that in R we're going to just divide one matrix by the other, just like we can do with vectors, right? So let's do that. Let's say field goals divided by games. Let's check that out. Now this is way too big of a matrix, so let's run it again. Let's make some space, and there we go. So now you can see how many field goals per game each player scored. If I round this, and I don't give any parameters, if I just do that, or maybe let's give it one number after the decimal, then here you can see how many field goals each player actually scored per game, and it's presented nicer than that. And let's say you want to find out Chris Paul in 2010, here you go, on average he scored 5.4 goals per game. And that is what this table is about. That is how a matrix is divided by another matrix in R. It's just simply element by element. So as you can imagine, they have to be of the same size for you to be able to perform this operation. All right, let's have a look at another one. What other tables do we have? Let's bring this back, and here we've got, let's say, minutes played, right? Let's find out how many minutes per game did each player play. So let's do that. Minutes played divided by games. And once again, not enough space. And let's round that. Let's round that to the nearest one decimal point. So, or actually no decimal points for minutes played. So here we can see how many minutes on average per every game each player played in every single one of these seasons. So you can quickly tell, like Derrick Rose, 29 minutes per game over here, then 37, 35, then he was injured, then 31, then 30. And looking at per game stats is actually quite handy, because if you just look at minutes played, what you'll find is that here Derrick Rose only played 311, and you can't compare to the other players, or you can't even compare to the other years, because it's a very low number, or even zero here. But if you divide by games, or what we already have here, it's much more comparable. So you can now compare between different players and between different years, because 31, here you can see that even though he played only a few games, he actually played more minutes per game than in 2014. Okay, so that's how you divide matrices. It's the same thing, you can add matrices, you can subtract them, you can multiply them. In our case, it's just that the type of data set we have, we're mostly going to be dividing one matrix by the other. And but nevertheless, you can still do all those other operations with matrices. And so that brings us to the end of today's tutorial. In the next tutorial, we'll find out how to actually visualize these results that we're getting. It'll be a fun tutorial. We'll start building charts and graphs. And for now, what I would like to do is to invite you to explore these other matrices that you have here, and perhaps perform some other operations, like try to calculate the field goal attempts per game, or another good one would be try to calculate the field goals per field goal attempts, and that will give you the accuracy of each player. So you will know how many of the shots that they actually make end up in the basket. Okay, that brings us to the end. And on that note, I will see you on the next tutorial. Until then, happy coding! Hello and welcome back to the course on R programming. And today we're finally going to talk about visualization. We're going to create some charts and graphs. And in particular, we're talking about the matplot function. So let me type out the name of the function here, matplot. And let me give you a quick overview of this function. So we'll start by bringing up the help. And here you'll see that this function is designed to plot columns of matrices. Now, bear in mind, we won't be using this function a lot. We'll just use it in this section, and then there'll be more powerful tools that we'll learn. But for now, this function will do. So what does it do? Matplot takes in quite a lot of parameters. So don't get scared. Don't get put off by all of these parameters. We will go through the ones that we need, and I'll show you the values that we will need to input. So X, Y are vectors and matrices of data for plotting, and the number of rows should match. So I'm not going to read through all of this. Basically, you supply some data for these parameters. Then type is what kind of plot you want. Do you want a line? Do you want dots? Do you want characters, and so on? So then we won't be using these parameters. PCH is the character string or vector. So what kind of, if you're plotting points, then what kind of images do you want in those points? Do you want dots? Do you want X's? Do you want triangles? Do you want squares? Then col is for color, and that is you need to supply a vector of colors. And that's pretty much all we will need. We won't be delving into the rest of these parameters. So let's go ahead and check this out in practice. So matplot, right? We'll start off by plotting a simple matrix. We'll just choose field goals, for instance. We want to visualize how the players have been scoring field goals over time. Now, the important thing to note here is that we can't just supply field goals, because that would be incorrect. The matplot function plots columns of matrix one by one. So what it will plot is, if we look here, so let's just run field goals, right? Field goals. If we run this table, what the function will plot is it'll plot each column. But what we want to plot is we want to plot each row, right? We want to plot this player as one color, this player as another color, this player as another color, and so on. We want to see how the players have been progressing through their career. So how do we get that? How do we change this table to be able to put it into this function properly? Well, we need to transpose it. And if you're not familiar with the operation, the mathematical operation of transposing, that's okay. That's totally fine. What transposing means is it basically means flipping this table and changing the rows into the columns and the columns into the rows. There you go. It's as simple as that. A very complicated word for a very simple thing. And how do you transpose a table in R? It's very easy. You just type in T. That's the name of the function, just T. And then you type in, you put your matrix into the function. That's all. So if I run this now, let me make some more space here, and let's rerun this one. If I run this now, you can see that the table has been transposed. So here's our field goals table, and this is our transposed field goals table. So you can see that now the columns represent the players, and that's exactly what we want for the matplot function. So just be careful of that whenever you're using the matplot function. Check if the columns are actually what you want to plot, or if that's not the case, if you want to plot the rows, then you need to transpose your table. All right, so there we go. We've supplied the data. Now matplot knows what to plot, right? So pretty much we could run it right now. So let's make some room here, and let's run it for the first time. If we run that function, you can see that something has been plotted. It's not exactly what we want, right? It's just numbers. There is already some like trends, but let's make this look nice, right? That's what we're going to do. We're going to select a type, and type is going to be B. So once again, you don't need to know all of these off by heart, because one is you get better as you practice R. Two, we won't be using matplot a lot. So let's just select type B, which will be for these characters that we're going to select. And the characters or the pictures are going to be 15 to 18. So just type in these parameters, and the last thing is colors. So we need a vector of colors, and the colors we're going to use are going to be 1 to 4 and 6. So if I run this now, you can see it's much better, right? So I've got better colors, I've got a much more legible plot. The only thing I don't have is a legend. I don't know which player is which color here and which shape. So there's actually 2 black colors, 2 blue colors. Which player is who here? So to add a legend, we can simply add a legend here by calling the legend function. So this is us using the matplot function and legend function, which are built into R to build a chart. And the legend is going to go on top of the existing chart that we've just created. So to build a legend, very simple. We have to say where we want the legend, bottom left. Then after that, we want to say inset. That's how far it'll be moved away from the bottom left and the corners of the chart. Then we want a legend. What is the legend going to actually represent? It's going to represent the players. What does players mean in this case? Players is that vector, which you can see here, with the player names. Because we know that this vector was actually used to create the columns, the rows of the matrix. So we know that these rows are actually stored in this vector players. So let's go ahead and actually use that vector. And then we're going to use colors. So we're going to use exactly the same colors. Let's just copy that. So we want the colors to match. And then we want to use these pictures. And last, we want horizontal equals false. So we want a vertical legend. So quite a lot of parameters here. In your own free time, you can explore using the question mark, the legend function. But in short, this is what we're going to use. Basically, you can see that we're using the same colors and the same symbols for our legend as for the chart. And the important thing to note here is that this way, that's why I'm saying we're not going to use a lot this function and this type of approach to visualizing a lot, because here legend is absolutely separate to matplot. It's actually just going to happen to appear on the same chart once we run this line. But in reality, they are 2 separate objects. And if you, by accident, give the wrong colors here, if you supply the wrong color, different colors here, then your legend will be misleading you because it will be telling you the wrong colors for the wrong players. So it's you have to be very careful when you supply the symbols and the colors and also the data. So here players has to be associated with the players used in the data. It's just that our data is pretty clean and nicely formatted, so we're lucky that way we can do this. But for more complex situations, they are much more powerful tools, which we'll explore further in the course. And then you will look back on today's tutorial and you'll think, wow, that was very, very inconvenient. Anyway, so let's run this legend function. And as you can see, now we have a legend on our chart. So Kobe Bryant is that color. That's Joe Johnson over there. So now you can explore how many field goals each one of these players has scored, right? Throughout their career. You can see clearly that Derrick Rose is this blue color over here because he didn't score any goals in this season. He was injured. I'm not picking on Derrick Rose. I think he's a great player. It's just a great example for our data set to verify that we are visualizing what we want, because we already know that Derrick Rose wasn't playing in that season. And so here, yeah, you can visualize the data and you can see the trend. So you can see that kind of generally going down. But once again, just visualizing field goals isn't very accurate because the players play different games and this chart doesn't reflect injuries. So, I mean, like, injuries are not taken into account. The best way to take into account injuries is if you divide by the number of games, for instance. Or so, like, if you normalize your data. So in this case, we're dividing by the number of games, and that's how just our transpose should divide here. If we divide by the number of games and we plot this now you can see the actual picture, right? So here you can see what has been going on, and the legend is the same. So you can see which players actually score the most field goals per game they play. Okay, so that's how you visualize. Let's just visualize one more, and then I will let you explore the data and let your imagination run free. All right, so let's say we want to visualize field goals divided by field goals attempts. That's going to be an interesting one because that is the accuracy. That's what we talked about at the end of the last tutorial. So if we divide field goals by field goal attempts and we visualize that, you will see that we are now looking at the accuracy that these players have. So can you see this line up at the top? That is the most accurate player. And who's that? It's Dwight Howard. Dwight Howard, sorry. Dwight Howard is the most accurate player. His accuracy is like way above, and it's pretty consistent in the past years, right? Some players, their accuracy is up and down. So Kobe Bryant, for instance, his accuracy has been dropping. Who else do we have here? We've got LeBron James, but his accuracy dropped. So sometimes the accuracy drop can be due to injury as well. So if they had an injury and then they did come back to play, then, for instance, they could still be not performing to their best. All right, so there's a couple of visualizations. Now you've got this template. I invite you to explore this data set and see what you can do. And let me just remind you what tables we have. We've got field goal attempts, field goals, games, minutes played, points, salary. So you could look at things like, let me give you a couple of ideas. You could look at salary per point. So how many dollars per point do they get paid? Points per game. You could look at minutes, points per minute played. So how many points do they score on average per minute of their game, and so on. But don't get too carried away. Just have a look at a couple and then come back to the next tutorial, because we will be moving on and we'll be continuing on working with this data set throughout this section. So sooner or later we'll come back and we'll visualize some more, and yeah, we'll explore the data together as well. And I look forward to seeing you on the next tutorial. Until then, happy coding.